Hello everyone, welcome to my YouTube channel. So today I'm really happy to start this new learning series with all of you. So in this series, we're going to cover grade 10 CBSE mathematics chapter by chapter in a very simple and easy way. So today we will start with chapter 1, and from now on I'll be uploading a 30-minute video every day, and each video will be easy for you to understand and also will have step explanation which will be perfect for your revision for your exams. Okay. And all these videos will be in one playlist, so you can follow the full series in order without missing anything. And okay, so if maths feels difficult or confusing for you, do not worry, we will learn it together slowly and clearly. Okay. Also, please subscribe to my channel, uh, turn on the bell icon, and support me. So, without wasting much time, let's start our grade 10 maths journey with the first chapter, that is real numbers. Okay. So, before starting with the chapter, before learning about any new concept inside the chapter, we need to understand the meaning of real numbers. Okay. So, what is real numbers? Real numbers are a huge set. Okay. It is the biggest set of numbers which include all the numbers, all the other types of numbers that you might have learned in the previous classes, like natural numbers, whole numbers, integers, etc. So real numbers are basically all the numbers that we use. Okay. Real numbers are all the numbers that we use in mathematics and in our daily life. Okay. In our daily life as well as in mathematics. And, sorry, okay. And real numbers include all numbers like natural numbers. You know that natural numbers start from 1, 2, 3, 4, etc. until infinity. And it also includes the set of whole numbers which start from 0, 1, 2, 3, and ends, goes until infinity. It also includes the biggest set of integers which starts from minus infinity, minus 3, minus 2, minus 1, 0, 1, 2, 3, etc. until plus infinity. And it also includes rational numbers, which you might have learned in class 9th. So the definition of rational numbers are the numbers which can be expressed in the form p by q, where p and q are both integers, and q should not be equal to 0. That means rational numbers are a bigger set than integers. All the integers are a subset of rational numbers. Rational numbers include more numbers. Apart from the integers, it also includes decimal numbers. Okay, that means fractions. So rational numbers, we can say a few examples of rational numbers as 1 by 2, 0.75, 3 by 5, minus 7 by 4, minus 0.25, um, etc. Okay, 7 by 3, etc. So all those decimal numbers, fractions, along with the negative, positive integers and 0, it comes under rational numbers. And there is also one more set of numbers that you have learnt about, irrational numbers. Okay, irrational numbers. So irrational numbers are numbers that cannot be written in the form p by q, where p and q are both integers and q not equal to 0. That cannot be written as a fraction p by q. Okay. So numbers that cannot be written as a fraction are called as irrational numbers. The best example is pi. Okay. pi, root 2, root 3, etc. Okay, all these numbers are the numbers which are which will not show any pattern. Okay, for example, the number pi. Okay, irrational numbers. I hope you might have already learnt about irrational numbers, but let us understand more. The value pi is equal to 22 by 7, or it is equal to 3.14, and it does not end at 1 4. It goes on till infinity. It does not end anywhere. So if you divide 22 by 7, you get 1 0 1 7 3 0 4 28 2 0 2 14 6 0 8, and it goes on till infinity. Okay, which means it is non-terminating and non-recurring. It is not repeating. The pattern is not repeating, which means it is non-recurring, non-repeating, and it is also non-terminating. It does not end anywhere. It does not terminate anywhere. So it is non-terminating and non-recurring. These type of numbers which are non-terminating and non-recurring are irrational. Okay, they are all irrational numbers. Okay, so our aim is to understand what real numbers are. Real numbers are all the numbers. Okay, every number that you can find um, comes under the set real numbers. Okay, so the real numbers include natural numbers, whole numbers, integers, rational, and irrational numbers. So all numbers that can be placed on the number line are called as real numbers. So you can say that examples of real numbers are -5, 0, 2 by 3, 3 by 4, -1.5, root 2, pi are all examples of real numbers. Okay. So that was just an introduction of the chapter. So you need to understand what real numbers are. Next. Now, let us understand about factorization. Okay. See, in your textbook, you can find theorem 1.1, fundamental theorem of arithmetic. It says that every composite number can be expressed or factorized as a product of primes, and that factorization is unique apart from the order in which the prime factors occur. Okay, it is very simple. First, you need to understand what prime numbers and what composite numbers are. I hope you might already know what prime numbers are. Prime numbers are the numbers which have exactly two factors. Okay. Prime numbers are the numbers which have exactly two factors, that is 1 and the number itself. Okay, apart from these two factors, they will have no other numbers as factors. Such numbers are called as prime numbers. Examples: 2, 3, 5, 7, 19, 23, 71, etc. Okay. If you check all these numbers have only two factors, only two numbers as their factors. 2 has 1 and 2, 3 has 1 and 3, 5 has 1 and 5, 71 has 1 and 71. You cannot find any other factors for these numbers. Those type of numbers are called as prime numbers. So composite numbers are the numbers. All the numbers other than prime numbers are composite. Okay. So those numbers which have more than two factors, more than two factors are called as composite numbers, Examples: 4, 6, 12, 24, 91, 111, etc. Okay, all these numbers are composite numbers because apart from 1 and the number itself, they have other factors. For example, 4 has 3 factors, 1, 2, and 4. While 6 has 4 factors, 1, 2, 3, and 6. 12 has the factors 1, 2, 3, 4, 6, and 12. Right. While 111 has the factors 37 and 3 apart from 111 and 1. Okay, so all these numbers which have more than 2 factors are composite numbers. And a fundamental theorem of arithmetic says that a composite number can be expressed as a product of prime factors. Let us see. For example, let's take the number 91, sorry. The number 91 is a composite number, and the number 91 has the factors 1, 7, 13, and 91. Okay. So if you multiply 13 by 7, yes, you get 91. So these are the 4 factors of 91. Also, fundamental theorem of arithmetic says that you can express it as a product of prime factors. Prime factors. That means you should express it as a product of some prime number. Okay. 91 can be expressed as 1 into 91 as well as 7 into 13. 1 into 91 is not a product of prime numbers because 91 is not a prime number. But 7 into 13 is a product of prime numbers because both 7 and 13 are prime numbers. So the prime factorization of 91 is 7 into 13. Let's take another example. Let's take the number 12, which is obviously a composite number. The number 12 can be written as, if you do the prime factorization method, you can do it like this. Dividing 12 by the least number, that is 2, you get 6. Dividing 6 by 2, you get 3. Dividing 3 by 3, you get 1. So the number 12 can be written as 2 into 2 into 3, which is also equal to 2 square into 3, where 2 is a prime number and 3 is also a prime number. 2 and 3 are prime numbers, which means 12 written as 2 square multiplied by 3 is the prime factorization of 12. So always remember that in prime factorization method, you have to write the composite number as a product of prime numbers only. Always as a product of prime numbers. Okay, let us take one more example. Let's take a bigger number, 48. Okay, if you divide 48 by 2, you get 24. 24 by 2 is 12. 12 by 2 is 6. 6 by 2 is 3. And 3 divided by 3 is 1. So you can stop when you get 1. So 48 can be written as 2 multiplied 4 times. That is 2 raised to 4 into 3. This is the prime factorization of 48. Okay. Suppose, let me also explain one more method. Suppose if you do not want to write this prime factorization, you do not want to use this prime factorization method, then you can also write 48 as, first write it as a product of any two numbers that you know. Okay. I know that 48 is equal to 6 into 8. I know that 6 into 8 is equal to 48. Also, I also know that 6 is not a prime number, 8 is also not a prime number. So I need to convert this product into prime numbers. I also know that 6 is 2 multiplied by 3 and 8 is 4 multiplied by 2. Here, 2 is a prime number, 3 is a prime number, 4 is not a prime number, 2 is again a prime number. So let me convert this 4 also into product of two prime numbers. I can write this 2 into 3 as it is and write this 4 as 2 into 2 and write 2 as it is. So now I got the product as 2 multiplied by 3 into 2 into 2 into 2. That is 2 multiplied 4 times multiplied by 3. In this method also, you can get the answer. That means you will write the composite number as a product of any two numbers that you know, then convert it gradually into a product of prime numbers. Okay. You can use any method that you like. Okay. So in your textbook, you can find example 1 in which the question is to consider the number 4 raised to n, where n is a natural number, and check whether there is any value of n for which 4 raised to n ends with the digit 0. Okay, so the question is consider a number 4 raised to n where you don't know the value of n. Okay, you do not know the value of n. You need to check for any value of n. Okay, let the value of n be anything from 1, 2, 3, any value until infinity. For any value of n, will the value of 4 raised to n be equal to a number that ends with 0? That is the question. So, you need to understand that if a number ends with 0, it should be divisible by 10. If a number ends with 0, that number should be divisible by 10, which means it should be divisible by 2 and 5 both. It should be divisible by 10 also means that it should be divisible by 2 and 5 both. Okay. So, the number 4. Okay, number 4 raised to n can be written as 4 into 4 into 4 into 4. And it goes on till n times. Right. Anyhow, there will be only number 4, no other number except 4. So this 4 can be written as a product of prime numbers as 2 into 2, that is 2 square. Okay, so 4 into 4 can also be written as 2 square. 2 square into 2 square into 2 square into 2 square. No further prime factorization is possible. This is how I prime factorized 4. So in the whole in this whole multiplication, only 2's are involved. Okay, only 2 is involved. 5 is not at all involved. Okay, if only 2 is involved, which means the number 4 raised to n will be divisible by 2, but not divisible by 5. 4 raised to n will be divisible by 2, but it will not be divisible by 5. Okay, it will never be divisible by 5, which means it will never be divisible by 10. If it has to be divisible by 10, it has to be divisible by 2 and 5 both. It is divisible by 2 but not divisible by 5. Hence, it will not be divisible by 10, which means it will not end with a 0. Okay, it will not end with a 0. I hope you understood. Okay. Now that we have learned prime factorization method, let us learn how to find out the LCM and HCF using prime factorization method. Let's take the numbers 36 and 24. You need to find out the LCM and HCF of these two numbers. Okay. It is very easy. You need to prime factorize 24. You also need to prime factorize 36. Okay, first. Okay. If you prime factorize 24, you will get 24, 12. 12 divided by 2 is 6. 6 divided by 2 is 3. 3 divided by 3 is 1. 24 is 2 cube multiplied by 3. And 36, when I prime factorize 36, you get 18 divided by 2 is 9, divided by 3 is 3. 3 divided by 3 is 1. 36 is 2 square into 3 square. So you know how to prime factorize a number. Now you need to understand how to find out LCM and how to find out HCF from the product of prime factors. In order to find out LCM, you will take each prime factor once and take the highest power of each of those prime factors. Okay, in order to find the LCM, you need to take each prime factor only once, okay, once, and consider the highest power, underline the word highest power of each prime factor. You take each prime factor once and consider the highest power of each prime factor. Here we have only two numbers. In both cases, you have only two numbers, that is 2 and 3. So you take both 2 and 3 once and take the highest power of each prime factor. The highest power of 2 among 2 raised to 3 and 2 raised to 2 is 3. So you take 3, and highest power among 3 raised to 1 and 3 raised to 2 is 2. Then you take 2. And this will be the LCM of 24 and 36. That will be equal to 2 cube is 8 and 3 square is 9, which is equal to 72. Okay. So in order to find out the LCM, you take the prime factor, you take each prime factor once and consider the highest power of each prime factor. Now, let's understand how to find HCF. Since 24 is equal to 2 cube into 3 and 36 is equal to 2 square into 3 square, HCF, in case of HCF, you will consider only the common prime factors, and take the smallest power of each common prime factor. Take only the common ones, okay? Common prime factors among the two and consider the smallest power of each common prime factor. You take the common prime factors only and consider the smallest power of each. So here the common prime factors are in 24 and 36, you have 2 common and you also have 3 common. In 2, you need to consider the smallest power. Among 3 and 2, the smallest power is 2. And among 1 and 2, the smallest power is 1. Which means the HCF is 2 raised to 2 into 3 raised to 1, which is equal to 4 multiplied by 3. That is equal to 12. So in case of HCF, you will only consider the common prime factors. While in case of LCM, you consider all the prime factors once, whether it is common or not, and take the highest power. Here you consider only the common prime factors and consider the smallest power of each prime factor. Okay. So a question is given in your textbook is example 2, which you can work out. I hope you will be able to do that. And you have also a bigger numbers. You need to find out the HCF of 96 and 404 by prime factorization method. You can try that question as well. Now, let's try to find out the HCF of 3 numbers, 6, 72 and 120. Okay, let's do that example as well. In order to find the HCF of 6, 72 and 120, we follow the same method. Write 6 as a product of prime factors. 6 is 2 multiplied by 3. Write 72 as a product of prime factors. If you prime factorize 72, you will get 2 cube into 3 square. And if you prime factorize 120, you will get 120 can be written as 12 into 10, which is equal to 2 square into 3 into 2 into 5, which will be equal to 2 cube into 3 into 5. Okay. So we said that HCF, in case of HCF, you consider only the common factors, only the common prime factors, and take the smallest power of each. 2 is common in all the three, so I consider 2. 3 is also common in all the three, so I can consider 3 as well. But 5 is not common in all the three. 5 is there only in 1, so I do not consider 5. In case of 2, I consider the smallest power, which is 1. And in case of 3, I again consider the smallest power, which is also 1. So the HCF, highest common factor, will be 2 multiplied by 3, which is equal to 6. Let us also find out the LCM. So in case of LCM, you not only write the common factors, you write all the prime factors once. That is, you write 2 ones, 3 ones, and 5 ones. So all the factors are done. Now we take the highest power. In case of 2, the highest power is 3. In case of 3, the highest power is 2. In case of 5, the highest power is 1. Okay. So 2 cube is 8. 3 square is 9 multiplied by 5, which will give you 360. Okay. So the LCM of 672 and 120 is 360, while its HCF is 6. Okay. I hope you understood. We will start with the exercises in the next class. So in the next class, we'll understand more about prime factorization and also new concepts, and we will solve even more questions. Okay. Thank you everyone for watching the class. Stay tuned till the next video. Thank you.